Looks like the sea is turning into a spinning drain, but it's not a hole. It's tidal power being squeezed, twisted, and turned into a vortex. Stay till the end, because one of these whirlpools is officially called the largest in the Western Hemisphere, and it helps feed marine life. Whirlpools form when moving water is forced to speed up, turn sharply, or collide with other flows, especially in narrow straits and over uneven seabeds. Big, dramatic whirlpools often get the name Maelstrom. And here's the key. Many of them peak on a schedule, the tide schedule. Saltstraumen, Norway. Up to 400 million cubic meters of seawater forces through a narrow strait every 6 hours. That's why the surface can look like it's boiling and spinning. At peak flow, Saltstraumen is reported to produce vortices up to about 10 meters across and around 5 meters deep. Real, measurable, and absolutely not something you casually paddle into. In Japan's Naruto Strait, the best time to see the whirlpools is about 1.5 hours before and after each tide, because that's when the current is strongest. And the size? Travel authorities note these whirlpools can reach up to 20 meters in diameter. That's the width of a small building. In Scotland's Gulf of Corryvreckan, strong Atlantic tides and rugged seabed topography create a violent tidal race. Flood flows reportedly reach NAR 8.5 knots, forming whirlpools and standing waves. The reason it gets so wild is the seabed. Sources describe a deep hole and a rising pinnacle that distort the flow. That interaction helps generate the famous overfalls, whirlpools, and surface turbulence. Now the mind-bender, the Lofoten Maelstrom, Moskstraumen, is unusual because it's open ocean, not a tight river channel. Peer-reviewed research on wave current interaction there notes the tidal current can reach at least 3 meters per second. In British Columbia, Canada, Skookumchuck Narrows, the provincial park notes current speeds can exceed 30 kilometers per hour, and the rapids are famous for whirlpools and whitewater. Here's why it explodes into chaos. The same official source says the difference in water levels between one side of the rapids and the other sometimes exceeds 2 meters. That height difference helps drive the violent flow. Old Sow, near the Bay of Fundy region, NOAA describes it as the Western Hemisphere's largest whirlpool. NOAA also warns it can be dangerous to small craft, but its swirling motion creates upwelling, lifting nutrients and tiny sea creatures toward the surface, basically setting the table for fish and seabirds. So no, these aren't permanent ocean drains. The drama peaks when the tide-driven currents peak. That's why official and tour sources talk about specific time windows tied to tides. Quiz: what makes tidal whirlpools bigger? A. Wind only. B. Narrow straits, plus strong tidal windows. C. Hot water. Answer is B. Narrow passages and strong tide windows supercharge the flow. If you enjoyed this, subscribe for weekly Geo Wonders. Next episode, places on Earth that feel alien. Comment alien and tell which you'd visit. Norway, Japan, Scotland, or Canada.